This is radio TV phono nut and something in for repair today off of the mountain of stuff over here. This is I believe a 1951 Sears Silvertone. It was made by Waters-Conley for Sears, 3-speed phonograph. And this is actually a pretty nice one. This has a 2-stage amplifier in it, 50L6 output tube and a 12SQ7 driver's tube. And it's funny, I've got another Waters-Conley Phonola branded unit that's almost identical to this, except it's in a gray case, and that one uses miniature tubes. And I'm glad this one uses the octal tubes. I don't know whether it's just my imagination or what, but I think the ones with octal tubes sound better, and the tubes and the sockets that they go in definitely hold up better than miniature tubes. So yeah, I'm happy about this. Alright, let's turn it on and see what it does. It may shoot fire and flames everywhere, I don't know. Well, I think we have a bad filter capacitor. I can tell that the drive wheel has multiple dents and notches in it. It's trying to come up to speed. Yep, filter's bad. Cartridge appears to be very close to being dead. As I've set on the 8, I think this uses a 2mm single tip needle, which was supposed to be an all-speed needle. I'm not getting very little out of this, so but that's okay. This one's a good candidate for one of those modern P228 stereo cartridges, which will be a vast improvement over what's in here anyway. And I'm going to give you some tips about how to change those and why I order my cartridges from the Voice of Music website in just a minute. But first, let's get into this and see what we're up against. We'll just take it one step at a time, do the amplifier and cartridge, and then we'll tackle the drive mechanism. And here's the amplifier, nice and spacious. I like nice and spacious, and we have a front-mounted 4x6 speaker, and I unsoldered the rest of it from the speaker so I could get it out easier to work on it. When I get this done, this should have a decent sound to it. This could almost be a classroom record player. So here we are, all opened up and exposed. I see 5 paper capacitors that need to go, and of course this multi-section electrolytic, and then we'll test the resistors and get any of them that are out of tolerance and replace the selenium rectifier with a silicon diode. So yeah, this looks to be a bit nicer of an amplifier than what's normally found in these types of record players. Usually you find a little one-tube wonder with no more than 2 capacitors for besides the filter cap. And I've seen some cheapy one-tube wonders that didn't have any capacitors in them besides the filter capacitor. You had a hot chassis and no tone control circuit, so no capacitors needed. Okay, we're getting there. I've replaced all of the capacitors and a couple of resistors that were out of whack. I tried to do direct terminal soldering with the new capacitors, but in a couple of instances that wasn't possible because these newer parts don't have as long a leads as the old parts had, so in a couple of cases I had to splice onto the existing cap lead, but when I did that I insulated everything with heat shrink tubing, so everything will be short proof. Here's our new filter capacitors. This is an aluminum chassis, so I wasn't really able to solder my terminal strip to it like I normally would, so I just once again attached the new capacitors to the old leads, ran heat shrink over everything, and secured them in the old strap that the original filter capacitor was in. At this point, the only thing left to do is replace this selenium rectifier with a diode, and this power cord's kind of hard and on the verge of cracking here where it goes into the chassis, so we'll want to replace that. But right now I want to run a test and just see where we are at this point and check the voltage coming off of the original selenium rectifier, and that'll kind of give us an idea of what voltage we need to shoot for with the silicon diode, since the silicon diode is way more efficient and doesn't have nearly the voltage drop across it that this does, making it necessary to put a resistor in series with the new diode. Well, the amp appears to be working. The cartridge appears to be dead. Yeah, we're not getting anything out of that cartridge. And this drive mechanism, yeah, it needs some serious help. Although I will say the sound of this noisy drive mechanism is actually more entertaining than what you'll hear on most radio stations today. Here's the old dead static cartridge. This was a popular cartridge in the early 50s. Now it's a dead cartridge. And yes, this is indeed the type with a 2mm stylus for playing all record speeds. And of course this is not stereo compliant, so we're going to replace that with something that is stereo compliant and has a flip over needle for LP and 78. Yes, this amp is hot. Very nice. And we're getting 126 volts off of the output of the rectifier, so we'll shoot for somewhere in the 130 to 35 volt range. It should be happy with that. A little more B plus never hurt. We don't want to go hog wild, but you probably want to take into consideration that this rectifier has lost some of its capacity, and when these selenium rectifiers get old, the output goes down on them, so there's a strong possibility this is not as stout as it used to be. Okay, here we are, all done with the amplifier. The original AC input resistor was a 39 ohm half watt. I went with an 82 ohm 2 watt. With the original 39 ohm resistor, our B plus was about 148 volts. The original voltage measured off the selenium rectifier was, what did I say, 126? And with an 82 ohm resistor, that got us down to about 137 volts. So that's roughly, we'll just round it off and say 10 volts higher than the originally measured voltage. So we'll go with that. Like I said, a slight boost won't hurt anything. Now I'm going to talk to you a little bit about this cartridge. This is a Fansteel P228D. It's a knockoff of a Varco TN8U. You can get these from a variety of vendors, but I like to get them from the Voice of Music website, VM Audio Enthusiast, voiceofmusic.com on the internet. And here are a few reasons why I like to get this cartridge from Gary. The first reason, the version available from him comes with a LP78 flip needle, while the ones from other sources generally only have an LP flip needle. And of course you could order a LP78 needle from one of those other sources, but that's just added money. Why do that when I can already get the cartridge from Gary with the needle already supplied? Now of course if I only need a dual LP flip needle, that option's available too. Another reason is the needle that this comes with. This comes with the Fansteel 865 DS series needle. It says DS77 on the box, but that's the Diamond Sapphire LP version. This is the 78 version. What you get from other sources comes with an 864 needle, but this 865 needle is a special needle that has a slightly shorter cantilever, which gives the cartridge a little more output. I think about 0.8 volts versus 0.5 volts with the 864 needle, and that little bit of boost is often needed in these vintage record players that originally had a 1 volt to 1.5 volt cartridge. A lot of times in those, half a volt just simply won't cut it. I mean, even the 0.8 volts is not optimum, but it's better than 0.5. Here's reason number 3 I like ordering from the VM site, because this cartridge comes with 4 clips that actually have the through hole that you can solder a wire to, and in the case of bridging from stereo to mono, which we need to do on this player, we have 4 wires here with clips already attached that make it very easy to do that. Now, if I were to order this cartridge from another vendor, it would only come with 4 of those little crimp style clips that I don't like one bit. I despise them. And yes, I can use them, but it's so much easier to get the one from Gary that generally has everything I need with it to use in these older players like this. And here's an example of one of the little crimp-on connectors that I dislike. Now I'm going to show you how to prep the cartridge for installation. And first we want to start with getting our wiring in order. And I find it a lot easier to do that if you have an old dud cartridge that you can slide the connectors onto to prepare them. You don't want to slide them on the new cartridge and solder to them, because the heat transfer will screw up the new cartridge, or it's highly possible that it will. Now, let me give you another note of caution. This cartridge you see here is an Arista replacement for a BSR 4-volt crystal cartridge. I found this on eBay for a cheap price, and I really went against my rule as far as not ordering cartridges from eBay unless it's from a seller that specializes in cartridges. But this one was cheap, and I said, what the heck, I'll give it a try. If it's good, I can put it in one of these one-tube wonders and won't have to modify the amplifier. Well, unfortunately, it was stone dead, as well as another Arista brand cartridge that I got a while back off of eBay. So unless you've got money to burn, order your cartridges from a reputable vendor, not some A to Z eBay flipper who found a box of junk at an estate sale or a TV shop clean out that he paid $20 for the whole thing, and because they have no way of testing these things, all they can do is put them on eBay, and if they work, great. If they don't, then you're up a creek. And some of those clowns on eBay are not exactly giving these cartridges away. I've seen eBay sellers charging $75 to $100 for these cartridges, which is totally nuts, because I can buy this one from Gary for $20, and it's a brand new, freshly manufactured cartridge. And even if I'm using one of these in a one-tube wonder and have to construct a driver stage, I'm still coming out a lot cheaper than spending $70 on eBay for something like this that may be dead when you get it. Now, I didn't pay $70 for this. Okay, here's cartridge lead number 1 shoved on our dud cartridge terminal. Now, as you can see, this lead is simply crimped on, and I have found that they're not crimped on very well, so when you try to bend the lead over, when you're trying to tie 2 leads together, this can come out of here. So what I like to do before I do anything is, after I've slid this over my dud cartridge connector, solder this in place, and that way it can't just simply come out. And then you strip off part of the insulation. The object of the game is to remove only part of the insulation, but if the whole thing should come off, like what just happened to me, it's no big deal. We can just slide a little piece of heat shrink tubing over that, and it'll accomplish the same thing. Okay, we tried to come up with some red heat shrink tubing, but I happen to be out of that color in this size. But this thing don't care what color it is. It could be hot pink for all this thing cares. So we slid our heat shrink tubing over there, shrunk it down, twisted our wire together to make sure there's no little strandies sticking out, and then tinned it with our soldering iron and solder. And now we'll slide another connector on this side, and do the same thing that we did to this end, and then twist the two wires together and solder them. Okay, there we are. Now I didn't strip all the insulation off of number 2, but I still slid some heat shrink tubing over it just for a little added protection. Tied the two ends together and soldered them. Now that's our bridge for cartridge lead number 1. Now, taking a look at our tone arm wiring, we'll first need to unsolder the original cartridge clips and then slide some heat shrink tubing over each cartridge wire, and then connect this here, and then slide the heat shrink tubing back over here to cover the connection. There should be no chance of anything shorting out once we're done here. And here we go. Now we'll pull these off of the dud cartridge and repeat the same procedure for the other two connectors. What you see here will connect to the left plus and right plus of the new stereo cartridge. And then when I bridge the other one down here, that will go to the left minus and right minus. That way we're bridging the stereo output for mono, and that way when a stereo record is played, the output will be combined to a mono signal. And one other thing, when you're soldering the cartridge pins while they're on the dud cartridge, don't over solder like I just did, because if you do, the connectors will solder themselves to the pins, and then you'll have a heck of a time getting them off. And on that note, it's time to call it a day. We'll do the other two pins tomorrow and get this installed and get the mechanism cleaned up and hopefully have a decent record player. Okay, we have the cartridge in place, and once we installed everything, we took up the slack in the tone arm wire so it wouldn't be hanging down. And we're getting there. Oh, so now I guess this motor is gonna, there it comes. Let it warm up a bit. And as you can hear, Jimmy's kind of dragging a little bit. And this thing gets plenty loud enough. In fact, when you turn it all the way up, it squeals from feedback. So yeah, I'd say that's enough gain. Now there's still one other thing we need to do regarding the cartridge, and that's get the tracking pressure set right. I think the specifications are 4 to 8 grams for this cartridge, and I try to get them as close to the 4 gram end as possible, and I just use a digital scale for that. And if you'll look back here on the tone arm, this particular one has a counterbalance spring, and if I need to lessen the pressure, I can just very gently bend this bracket that it's attached to towards the front of the tone arm. And if I need to raise the pressure, I just gently bend it towards the rear of the tone arm, but be very gentle, because you don't want to break that little bracket off, because if you do, you're up a creek. We're up to, if that happens, we're back to finding a plastic kitty arm to put on this, and I really don't want to do that. I want to try to keep this as original as possible. Now, when we're measuring the tracking pressure, I want to have the gauge situated so the tone arm is as close to the same position as it would be in when playing a record as possible. So I think in order to do that, we'll need to take the turntable platter off, and then we can set our tracking pressure gauge here and then raise it up if need. And looking at our drive mechanism, this has 2 rubber wheels that need to be addressed. This main idler wheel has got a big dent in it, as well as this smaller wheel here. It actually has 2 dents in it, so that's why it sounds like an old pulpwood truck. The motor drives this rubber wheel here, which in turn rotates this capstan, and whenever you shift the speed selector lever, well, you see what happens. The wheel moves to different notches on the capstan to drive the turntable platter at the various speeds. This is what I consider an early multi-speed drive, so pretty much what they were doing then, they were taking their existing 78 only drive mechanisms and modifying them for 3-speed use. Yeah, 12.8, that's way too much. That exceeds the maximum recommended pressure for this. So let's bend our tab and get the spring a little more adjusted and see where we can go with it. Okay, we got it down to 5.8. Might leave it there. We don't want to press our luck and end up breaking that tab off. Well, it doesn't appear to be chewing up this styrene record, and Debbie Boone never sounded so good. Okay, the idler wheel comes off of here just like on any other mechanism. You take the clip off and the little washer and slide the wheel off. This comes off by removing the little clip in the washer that holds this to this shaft right here. Then you slide it up and flip it over, and as you can see, there's a little clip right here that must be removed, and be careful, you don't want it to go flying. And then this wheel here should just slide right off of this piece here. Here we go. Now, sometimes I can put these in a drill and use some sandpaper to smooth them out, but I think these are a little bit too far gone for that. The only way we're going to be able to do this correctly is to send them off and have them rebuilt, and unfortunately that'll be about $60 for both wheels. And once again, we'll depend on the VM website that I mentioned earlier for that purpose. So for now, we're going to put everything in a little snap container. And just for my benefit, this clip and the two washers hold the smaller idler wheel in place. This clip and the two fiber washers hold the idler arm in place, and the two washers go on top. And this clip and a washer holds the big idler wheel onto this arm right here, and I think they're the same size as these, so no real damage if we get the two mixed up. So for now we'll just table this until I can get the wheels rebuilt, but in the meantime let's have a look at the Waters-Conley version of this that I said is very similar, except it has a miniature tube amplifier. Here's the other one, and somebody has worked on this one before, which I'll show you in just a few minutes. Now, this one is a little noisy, but it's not as bad as the other one was. Okay, here's the cartridge. This is a flipper, but I can tell it's not original because some dolt soldered the leads directly to the cartridge, and I know that would have never come from the factory that way. And just as an experiment, I believe we're going to install an static 89T in this one, which has an output of 1.3 volts versus 0.8 volts for the Varco cartridge. And I just want to do a little sound comparison and see which one sounds the best. I figure the 89T will sound a little more bold, and you might get a little more bass than with the P228, but the P228 will be more compliant and more record friendly. Okay, here's our 89T holder installed, and a couple of tips on doing that. Plug a dud cartridge into it when you're soldering the wires, because that'll help keep the plastic from melting and the terminals from shifting position. Also, I like to slide heat shrink tubing over the connections, because I can't tell you how many of these I fixed in the school record players, where the wires will break off from the terminals from constantly being flipped back and forth from LP to 78. So putting the heat shrink tubing over the terminals kind of offers a little bit of strain relief there. You hear me call you. Yeah, that sounds much better. Through the sunshine, sweet and clear. Okay, I got it to about 7.3 grams, and that's pretty well within range for an 89T. Alright, as you can tell, this amp has been worked on, but whoever did it was a bit sloppy. Look at this filter capacitor here. They just have it held on with a block of silicone, and if this cam was were to touch this chassis, that would make it a sure enough hot chassis without any type of capacitor isolation. And you can see here where they just tacked on the orange drops to the existing capacitor leads, and you can see what they did there as far as soldering a new selenium rectifier in here. I don't like that. This just looks sloppy, so every bit of this is going to have to be corrected to meet my standards. Alright, we're starting the cleanup process, and I noticed when they attached these capacitors to the stubby leads of the old capacitors, they didn't even make a mechanical connection. They just basically laid the capacitor on the leads and put a drop of solder on them, so all I had to do was heat the solder and off comes the capacitor. These Sprague orange drop capacitors are perfectly fine for reuse if I can get the leads situated to where I can get them in here like I want them neatly. Checking our cathode resistor, it's supposed to be 150 ohms, but it's actually reading 360 ohms. And yes, I'm using a cheap backup meter today. The other not so quite cheap meter is wanting to act stupid, so we'll have to use this one for now. Okay, this is starting to take shape, and this does look better. We have everything on this side soldered directly to the respective tube socket pin, and heat shrink tubing placed on the leads to prevent any kind of shorts. There were two resistors on this side that were way out of tolerance. You can see they've been replaced. Here's our cathode bypass capacitor, and since it's so much smaller than original equipment parts, we were able just to solder it directly across the resistor, and I gave it a little height here so it wouldn't be right jam up next to this resistor that could get a little warm. Now we got to fix this mess and got all kind of messes to fix. Okay, here we are all neatened up. I reused one of the orange drops. Everything else is new because the newer ones are smaller and easier for me to make them look neat. Had to J-hook a few of these because the leads on the capacitors weren't long enough, but everything has heat shrink tubing over it and is short proof and ready to go. So I think we'll put this back together and give it a little test run. Alright, here we go with a Elvis track you don't hear much anymore. Seems to be doing okay with a styrene 45, so that's good. I always keep a few of these junker records around just for testing purposes, because we don't want something that's going to instantly destroy records. Except for servicing the drive mechanism, this one's about done, but this one's going to need some rubber rebuilds too, just like the other one. This one's not as bad as the other one, but we still can't have this noise that we're having, and it's this wheel that's causing the bulk of the trouble. When you put this one in between speeds, it pulls the big idler wheel back, but it doesn't pull this one back. So on a player like this, if you leave it sitting up too long, it will cause a groove to form in the wheel here, no matter what position this is in. Okay, back on the Waters-Conley phonograph. I've already done some work to the drive mechanism. I didn't show it on camera because that part of it was routine. I took the spindle out and did the usual cleaning and Phonola treatment of that, and it turns nice and smooth now. We took the motor out and give it a good cleaning and lubrication, and it runs nice and smooth now. Now, to take note on this one, in order to get the motor out, you have to take off the two wheels in order to access the bolts here. And like I said before, you just take the main wheel off by removing the clip and lifting the washer off, and then the wheel comes off, and then the smaller wheel, you just take the little clip off and lift off the assembly that the wheel attaches to, and of course slip the little spring off back here, and then you can get to the bolts to get the motor out. Now, I cleaned this big wheel with rubber renew. I think we can salvage it. We might can put it in the drill and sand it down a little bit to get a couple of the minor little dents out of it. And we might try that with this one too. This one's not in as bad a shape as the other one is, but maybe we can put this in the drill and give it the sandpaper treatment, and that way I won't have to send these in. If I can get out of spending $60 for wheel rehab, that'll make me that much more happier. Now, I've cleaned as much of this as I could with the Q-tips and alcohol, but we still need to clean all this, and that's accomplished by carefully removing this clip and flipping this back, and this should lift out, and then we can remove this little clip and separate this piece from this piece, clean everything with the alcohol, and just put a very light layer of zoom spout oil on these shafts here. Just put some on a Q-tip and very lightly rub it on these shafts, and then put it all back together, and this here, clean it really good and coat it with some Phonola to where it'll shift smoothly, and then that ought to take care of it. And here we are removed. Now I'll just take the Q-tip and some alcohol and clean all this up a little better. And anywhere where it's obvious where metal on metal is rubbing here, I'll put a slight bit of Phonola on that to give it some lubrication. And like I said, clean all this off and Phonola it real good, and clean all this and lube it and put it back together, and it ought to be good to go. And now I'm cleaning this with a Q-tip dipped in alcohol. And then once we clean that, we'll clean all the surfaces of this piece and then reassemble everything. After we put a slight coating of zoom spout oil on these shafts here, and that you see there is hardened grease that is a result of a combination of heat from use and years. So I'm probably going to have to scrape that off with a little screwdriver. Okay, here we are in the drill. I'll just turn the drill on, use our fine sandpaper to very lightly remove the first layer of rubber here, and we'll sand down the metal capstan portion very, very lightly, just enough to get the roughness off of it. We don't want to sand down too much or our speed will decrease, but since these tend to run a little fast anyway, if speed goes down a tad bit, it probably won't matter. Okay, here we are, and that looks pretty good. I'll treat it with the rubber renew just for good measure, and then I'll take the Q-tip with a drop of oil on it and run the Q-tip down in this hole right here. Just enough oil to where it'll turn freely. We don't want to get carried away, because we don't want no oil or lubricant or anything else to migrate and make its way back to this rubber drive surface or these capstan steps here. Okay, it's still got a tiny little bump in it, but I don't think it'll be too distracting when a record is playing. It will eventually need to be rebuilt, but it's not nearly in as bad a shape as the other one is. Okay, we're ready to put the platter back on and give it a test run. Alright, 33, and we got plenty of torque. That's a test you want to make when you put it back together, is moderately press your finger against the edge of the platter. If it stops easily, then something's wrong, and that most likely something is there's some lubricant on the drive surfaces, and it only takes a microscopic amount to throw things off. Alright, let's get a record. Okay, before we get a record, let's find out why our amplifier's dead. Okay, I've got it wide open and just barely have any volume here, so we've got to go back in this amp and see what's going on with it. Okay, we're blown back apart, getting ready to take some voltage measurements on the amplifier chassis and see if we can determine why the audio decided to suddenly drop off to nothing. Okay, cathode 7.6, that's okay. Alright, let's see. I think our audio output stage is working. That's on the control grid plate. $125, that's good. Or excuse me, that was the screen grid. Yeah, plate, that's good, that's working fine. Alright, let's move over to the first audio tube and look at the plate voltage there. 108 volts. Yeah, that seems a little high. Okay, where's our control grid? Yep. I think this first audio tube may be bad. It's a 12 AV6. And touching this first audio tube, it's cool as a cucumber. Okay, that was definitely the problem. Popped in another tube. We have plenty of gain now. And let's see what our plate voltage is on that tube. Stay on there, darn it. 52 volts, that's about what it should be. Now what was happening, the old tube had suddenly decided not to conduct anymore, which was not placing any load on the B plus line to that tube, and no load means much higher than normal plate voltage there, but with a correct, good working tube in place, that places the proper load on our B plus line, which gets our B plus voltage to where it should be, and the high B plus voltage is what tipped me off to that tube being bad in the first place. Okay, well, I'd say this one's fixed. Okay, we've got the Phonola fixed as about as good as we're going to get it fixed. No, I did not send the wheels off to have them rebuilt. I just put them in the drill and sanded the heck out of them until the flat spots were gone. And last night I had it virtually quiet, but this morning I'm hearing a slight little bumpy sound in the smaller of the two wheels, and like I previously said, there's really no way around that because there's no disengage for the wheel. I can disengage the big wheel by putting the lever between speeds, but I can't disengage the little wheel or the turret or whatever you want to call it that's directly driven from the motor. So, you know, it's to be expected that if you leave these sitting up for any amount of time at all, they're going to develop a little bump in them. Just the key is to use them as much as possible, and oftentimes after they run for a few minutes, the bump will disappear.
Well, Johnny stepped down to the barroom, a bucket of beer. Oh, Frankie went down and said, "Hey, Mr. Bartender."
Get that off of there. We don't want no copyright strike. Okay, this has been on about 20 or 30 minutes, and that minor little notch in the wheel that was a result of it sitting overnight seems to have worked its way out. So, like I think I've already said several times, the key to preserving these things is to run them every now and then. Don't let them sit in the closet for 6 months or a year or 50 years. Yeah, even on 78, this thing runs relatively quiet.
In my home that I've never known before, and I don't know why she's there. At the age of 5, my mother fell a bee, the greatest man alive, but now I'm a man. Out of nowhere, out of nothing.
Okay, there's the Silvertone ready to go. I did the same thing to the wheels in this one, and I also replaced the P228 cartridge with the higher output 89T, just like in the other one, so they'll both sound alike. And this one seems to like the 89T better. With the other one, if I turn the volume up too high, I got feedback, and I don't really seem to be getting that with this one. That's wide open, and I'm not getting all the howling and squealing that I was getting. So we'll just go with a 89T for both of them.
I may be getting old, but I got the old-fashioned way. In wintertime he's inside, in summertime he's out. He burrows into holes, although he's really very stout. And that's what we know about a woodchuck. But what we don't know about a woodchuck is the answer to the problem that is strictly his. How much wood could a woodchuck chuck if a woodchuck could chuck wood? The woodchuck lives in a wood. Oh, I thought about you. Thought of the thing.
Alright, there you go. That's 2 more vintage ones fixed up and ready to go for a number of years longer, I hope. And I think the next video we're going to get back into some radios. I know we hadn't seen a radio in a long time, so let's get ready to do that. Well, before we go, here's another Silvertone in the same series of record players that we've been working on. Only this one's a couple of years newer. I think this one's from about 54. The internals are basically the same. The tone arm is a little bit more stylish, and this platter uses a rubber mat that's now dry rotted instead of flocking like the older ones have. However, this tone arm is going to need some repair. I'll try to show you here. See, there's a rubber grommet back here on the rear. It's supposed to cushion the tone arm, provide vibration dampening. Well, as you can see, that grommet has rotted all to pieces, so we're going to have to take this arm apart and find something else to replace it with. And when I got it, somebody had this old cartridge masking taped into the tone arm. This is a 1940s era 78 RPM crystal cartridge, which is totally wrong for this. Something like an 89T would be suitable for this one too.